Part 3 of our conic sections ellipse video series. This will be the last video I post on the ellipse. And in this video I'm just going to basically go through 3 examples where you're given the coordinates of the center, you're given the coordinates of one focus and one of the 4 vertices, and asked to basically graph the ellipse and figure out A, B, and C and write the equation. So here we go. Let's start with number 1 here. We're basically going to be looking at the center. We want to plot it 10, 3. So 10, 3 is over here. Focus is 6, 3. I'll put it in, I don't know, blue. 6, 3 is right here. So right away that tells me that if one of the foci is right here and the center is right here, the other foci must be on the other side of the center over here. And this distance is 4 units, so we want to count over 4 units over here to get our other foci. Alright, so your other foci, maybe I'll put that in here, is 10, 3. Nope, that's not true. It's 14, 3. Sorry. The center is 10, 3. Alright, one of the co-vertices is 10, 0. That's down here. We'll call that CV for co-vertices, co-vertex. And that distance is, of course, 3 units. So we're going to go up 3 units and put our other co-vertex. There's nice symmetry here. Alright. The only other question now are where's the location of both of the vertices. In other words, the endpoints of the major axis. And to get that, all we really need to do is think about what it means to be the distance between a focus and a center. Well, that is letter C. Remember, we have a nice relationship here if you're following along here. C squared equals A squared plus or minus B squared. And this distance from a co-vertex to the center, that is given by letter B, lowercase b. So lowercase b, C is, let's see, 4 units. So 4 squared is equal to A squared minus 3 squared. So 16, I'll write it up here, 16 is equal to A squared minus 9. 25 is equal to A squared, so A is 5. Now what that represents in our diagram in an ellipse, little a is the distance between the center and one of the vertices. So from 10 to 15, that's going to be one of our vertices. And over here will be the other one. This distance is 5 units, lowercase a. Alright, here comes the fun part. We're going to just basically connect all these vertices together. And I'm going to be really sloppy with mine because I figured out this new tool that I can use where I can turn that into an ellipse and sort of manipulate it as necessary. So I'm going to move mine a little bit up here. Let's see. Not perfect, but this will give me a pretty good idea of what this graph looks like. Let's see what that looks like. That's pretty good. You could probably make it go up a little bit higher, but not bad. Not bad. So the other question, of course, should be what's the equation of this ellipse? And the equation, remember, the center is at 10, 3, and that's h, k. So when we write this equation, x minus h plus y minus k equals 1, and this is a horizontal major axis, right? The ellipse basically is stretched left and right, so our major axis is horizontal. When that's the case, your a squared comes underneath the x binomial, and the b squared goes underneath the y binomial. And there you go. Now, it's usually good practice once you learn a skill is to practice it on your own. Try these on your own. What I want you to do is, just like in the first example, see if you can graph these 3 points in each problem. See if you can figure out the other focus, the other co-vertex, figure out the, in this case, the A, little a, and in this case again little a, and see if you can start filling in some of these blanks. So pause it now and try both of these. And when you're ready, just press play and I'll work on the problems for you. Alright, number 2. Hopefully you tried it and you're ready to go. Let's put the center in here, 4, 2. Negative 4, 2 rather, that's our center. Negative 9, 2 is one of our foci. So that distance, let's see, is 5. 1, 2, 3, 4, 5. So I'm going to go 5 over to this in this direction as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One of the co-vertices is negative 4, negative 10. So that's going to go all the way down here. So this is one of our co-vertices. That distance is, my gosh, that's 12 units. So I need to go up 12 from my center. Up 12 is going to be up here to 14. So that tells me that my ellipse is actually going to be, believe it or not, stretched out horizontally, which is hard to believe because the length of the minor axis is 24 units. That's quite a big, this is going to be quite a big graph. So again, think about what it means to be this distance right here. That distance is 5. Well, the letter that represents the distance from the center to a focus is letter C. Lowercase c is 5. The distance between the center and any either the co-vertices is lowercase b, and in this case that is 12. So we use our little relationship here. 25 is equal to a squared minus 144. So a is equal to 13. So 13 represents the end point of the, 13 represents half of the major axis. So we're going to go 13 this way and 13 this way and put our vertices. So let's see, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's one of our vertices. And 13 in this direction should put us at negative 17. Cool. So again, let's connect these dots. It would lead me to believe that this ellipse is pretty darn near a circle, so I would say the eccentricity is close to 0. And that's not the best graph in the world. Let me kind of slide it over just a little bit and maybe slide it down as well. The program that I'm using here to make all my videos is Windows Journal. And it does a pretty good job at stuff like this. I use this program to actually teach with during class. I just project right up on the screen. I don't really use PowerPoints too much anymore. Anyway, there's your ellipse. Again, the eccentricity is very circular, which means that our E value, which I mentioned in one of the previous videos, which is given by C over A, you can see is 5 over 13. 5 over 13. So it's one of those ellipses that is close, kind of close looking to a circle. It's not very oval ovalish or ovally or ovular. I don't even know what the heck the word would be. Whatever. So the center now will lead us into our equation. The center is -4, +2. So this is x plus 4 squared, y minus 2 squared. And again, the major axis here is left and right, so that means a squared goes underneath x, because left and right leads me to believe in horizontal direction. So that's going to be a squared, which is 169, which means b squared is underneath the y, that's 144. So there you have it. You know, you can fill in the rest of this, right? Your other focus is at 1, 2. Your other co-vertices, or excuse me, your other co-vertex is at -4, 14. If you wanted to write in your vertices as well, you would say 9, 2 and -17, 2. So there you have it. All right, hopefully you tried number 3 as well. I'm going to go through this one really quickly here. Hopefully you're getting the hang of this stuff. Center's at -7, 2. That is right here. That's my center. One of my foci is at -10, 2. So that would be right here. Again, this distance is c, and that would be 3 units. So I'm going to go over here to this point and put my other focus. So that would be, let's see, -4, 2. So that distance c, little c, is 3 units. One of my co-vertices is -7, 6. So that's up here. And lowercase b is, let's see, 4 units. So I'm going to go 4 units down. Put one right there. 1, 2, 3, 4. Yeah, that works. 1, 2, 3, 4. Cool. So that is the distance between the center and a co-vertex is lowercase b, and that is 4. So our relationship now will help us get lowercase a. Lowercase c is 3 squared. A squared minus 4 squared. So 9 is equal to a squared minus 16. A is equal to 5. So the center is 5 units away from our vertex. So there's our vertex. This direction as well. That would be -12. And you just connect them. And I'll kind of smooth that out a little bit. That looks pretty good. So there you go. And again, your other co-vertex is -7, -2. And your vertices are, let's see, -12, 2, and -2, 2. If you want to write your equation, which usually is a good idea, it's x plus 7 quantity squared and y minus 2 quantity squared. And we just set those equal to 1. Again, this is a horizontal orientation. I know that because my vertices are left and right, my foci are left and right, so everything, those 5 major points lie on that major axis. This is a horizontal ellipse. Horizontal ellipses always have the a value underneath the x value in the equation. And the other one is b squared, so that's 16. So there is your equation. Alright, that wraps it up. That was 3-part video series on the ellipse. If you watched the previous 2 conic circles and parabolas, so far we're up to, I think that makes it 8 videos in the conic section series, and we'll prepare ourselves for 3 more on hyperbolas. So I hope you enjoyed this, and again, if you have any questions on on any of my videos, just shoot me a comment and I'd be happy to help out. Make sure you subscribe so you don't miss any videos, and I will see you in the next one.